All right. So my plan for this week, we'll go over P today. We also will get into Q. I think Q will be pretty easy when we lecture about it. Once we've gone over P, R, S, and T lecture, and then we have U is kind of just review.
I don't like when you say lecture.
Sorry, get over it. Jeez. Y'all chose me, man. It was open enrollment. Y'all chose me.
I didn't choose you.
You didn't?
But it makes me feel better about myself when you don't put lecture. Well,
You didn't choose me? Is that what you said?
You're better. I chose you because Hannah and Peyton chose you. But I'm so glad.
So why did Hannah and Peyton choose me?
Why did I choose you? I'm
sexy.
Why would you say that?
And yes, we were recording, so about 48 seconds of the video. And we keep it in there just so we know that the context about it, how that came. All right. So let's. Oh, I gotta pull up my calculator as well. I'm just gonna start at the beginning.
Oh, we can do that too. Literally the whole paper.
You got it. All right. So looking at our paper, we have. It starts out with a T-shirt, right? T-shirt being shot out of a gun, or like one of those things they do at the football game, right? Oh my gosh, we have a snorter in class. That's best.
I'm gonna try, yeah.
I'm so done.
What is this?
Yeah.
I don't know what this one. We go over.
I'm gonna go over the whole thing, so I'll cover your question.
You are?
Yeah.
You have a copy of the homework?
No. But it's being recorded, so you can copy it when you get home. All right. So this is everything in this equation is already given it to you. So a few things to know. This is your initial velocity, which we call as V naught. This is your initial height, which we call H naught. Okay, the T is in time in seconds because we looked at it. It says where we get the time in seconds is when we look at the velocity. It tells us it's in seconds, meters per second or feet per second. This one is actually feet per second. This one we're using feet because the velocity told us it was doing feet per second as well, and that means that's all going to take in there. All right, so find the maximum height of the T-shirt. Find the time it takes the T-shirt to hit the ground. All right. So negative 16t squared. Let's get over here. Negative 16x squared. And then let's see what else we have. Plus 72. And then plus 36. So this T-shirt cannon is like 36 feet above the ground before it shoots it. It's not done at ground level. That's where that 36 comes from. We can take a look at our window. I like the -2, the maximum. Do I think this thing's going to be in the air much longer than 10 seconds? I don't know. We'll just go with what we have. X minimum of 3, maximum of 30. We'll see if it works. If not, we can go back and readjust it. Oop. Got to readjust it, don't we?
Yeah.
What do we adjust, X or Y? The Y max. So go back into window, and maybe we go to the Y max, maybe make it 60. I don't know. I'm just pulling values where I think, and if it's not high enough, still not high enough.
Do 100.
100, you got it. Jeez. All right.
150.
All right, 150. We'll go with that. Hey, we got it. We captured it. Awesome. So let's just look at some things in the context. What does where it crosses the y-axis mean in the context of this problem?
Where it starts.
Yeah, it was shot from 36 feet above the ground. So this is up on some platform, and then it shoots and comes down. Okay? This region right here, we ignore because we're not dealing with negative seconds. What does this point right here mean in context of the problem? When it hits the ground. And what does this mean?
Height.
Height. So there's two parts to that. The x part is the time in seconds it takes to get to its maximum height. And then the y part tells you that the actual height is in feet. Okay? So let's go through it. We're going to go second calculate. And we're going to figure out a maximum value. So that's number 4. And so I'm going to move my cursor to the left of it. Well, I know I missed it. I just wanted to make sure that I am definitely on one side or the other. So 2.25 seconds after this t-shirt is launched out of the t-shirt cannon, it got to a maximum height of 117 feet. Does that make sense? Can you all see that's the So you would make that as a point, parentheses, 2.25, comma, 1.1 or 117, comma, or parentheses. So that's a point. Okay? So A says find the maximum height. Maximum height, 117 feet. And then what does it hit the ground? Well, this is also called a 0, correct?
Yep.
So I go second calculate. I go to a 0. I want to make sure that there is a y sign change between them. So am I to the left of where that would take place? I'm very much above it. I'm even trying to squeak real close to it. So you hit enter. Notice that is a positive x value. Or excuse me, positive y value. So I'm going to move my cursor until I get to a negative number. I have a negative number. I'm now to the right of it. There has to be a sign change in between there. If you try and find a 0 and you don't have a sign change between your two y values, it'll tell you error, no sign change in dimension or something like that. Okay, that just means you didn't go above and below the x-axis. So looks like at about 4.95 seconds after this t-shirt was launched, it will hit the ground. Done. Problem number 2 says Jason jumped off a cliff in Acapulco.
Oh, I love that. Acapulco.
Yeah, apparently there's some cliffs there. So they have the equation given, so let's write this equation. So problem number 2, we have h at t equals negative 16t squared plus 16t plus 48. And so how high was just by looking at that, how high was the cliff that he jumped off of? 40. And do we know if it's in feet or in meters? What sticks out?
Feet.
Why is it feet, not meters? Because it says height in feet. The other thing that sticks out, if this is a negative 16, this is talking about feet. Okay? If it's negative 4.8, that's going meters. So the height of the cliff, so we'll call that h naught. Okay? We don't even have to graph it to know the maximum height or the height of the cliff. Now he jumped upward, so he went up, right? So what was Jason's initial velocity? Well, he jumped up at 16 feet per second. That's his initial velocity. We'll call it v naught. Okay, and then what was the highest point? So because he jumped up, he got a little bit higher than 48 feet. How much higher? We'll have to graph it to find out. And then, bless you. And then how many seconds before he hit the water? So I think we have enough information to graph this with our calculator. Agree?
Yes.
Okay. Pointer here. Oops, here. All right. Y equals negative 16, and that should be plus 16. All right. So we could leave our window like that. It's fine. I could see the whole parabola. Some people, I want to fit it to the screen. Okay, really? So we'll change our window if you really must. We'll change that to like 5. We'll change that to like 60, maybe. Well, he didn't jump up that high off a 48-foot cliff. Okay, so let's do some things in the context of the problem. What does the y-intercept represent? 0, 48. What does that represent? The height of the cliff. He got higher than the height of the cliff because he did what? He jumped up, right? So he jumped up. Make sure you wave at the camera. There you go.
Hey, Mom.
So he jumped up. So he went higher than the height of the cliff because he jumped up when he went. Okay? All right. So let's do this. Go second calculate. Let's find a maximum. So go on the left side of it. And as soon as you think you're on the left side of it, you're good. Hit enter. Go on to the right side of it. You're good. Hit enter. So 0.5 seconds into his jump, because he jumped up, he got up to 52 feet. So how high did he jump above the initial height?
4 feet.
4 feet. Okay? That's kind of a high jump, right?
Yeah.
4 feet's like here. Can you jump? Can you get your feet 4 feet up there? Most people probably can't. Man, this dude's Jason's he's like a jumping dude. He's part kangaroo or something. I don't know.
Yeah, that's quite a feat he accomplished for that.
All right. So what was the highest point Jason reached? He reached 52 feet above the water. He reached 4 feet above his initial platform he jumped off of. And then how many seconds? So this right here is where he will have hit the water. So it looks like just after 2 seconds. So let's figure that out. Second, calculate. We're going to find a 0. Thank you. Make sure you have a sign change in your y component. So on the left side of it, I'm at 21 here. I could have went closer, but I just chose there. So I'm now at a negative number. You have to make sure that's negative between the two. So 2.3 seconds, 2.3 seconds after Jason jumped off his cliff, he hit the water. Okay? So pretty good little jump. So feeling a little bit better about these?
Yeah.
The hardest part about doing this is dealing with the calculator. Though you're not doing the calculator wrong, sometimes your window gets in a spot where you're like, dude, I can't see my parabola, and you start to panic. All right. Number 3 says a soldier in a trench shoots an arrow from the ground level with an initial velocity of 112 feet per second. Okay, so let's go back to this window. All right. Okay, so there's an initial velocity of 112 feet per second. Yes?
Yep.
So if we want to write our equation, and he's on the ground.
+0.
So our ground level is 0 feet, and that would be our h naught. Okay? We good so far?
Yep.
So we're in feet per second, so we're going to use h at t is equal to negative 16t squared. Where did that negative 16 come from? Well, negative 32 feet per second squared is the acceleration of gravity. We divide by 2 because it's 1/2 that is where that comes from. And then we have a v naught.
Plus 112t.
112t.
+0.
Being he shot it upward is why it's plus. If he shot it downward, this would be a negative, okay?
Yep.
And then the ground is 0. So is this a vital part of the problem right here?
No.
You can put it as part of your question. You don't have to. Don't know where all the talking came from. I thought you guys were confused on this.
There's these bums that want to.
Okay. All right. So y equals negative 16t squared. What was that? That was 112t. Yes. No, it's up to you if you want to have that 0. It's a great point. It's going to be the exact same graph whether you put the 0 or not. If I'm looking at your equation and you gave me the equation as negative 16x squared plus 112x and left it, you're totally right. The 0 does tell me, though, that you have an understanding that you were at the ground level. Hey, if, let's say this guy was in a hole and he shot his arrow upward, what would you...
Negative.
It would be negative. Good. Does everyone get that?
Yeah.
All right. So, I'm not sure if this is good with my window. Let's take a look at the graph and adjust. We definitely have to adjust. Agree? Definitely have to adjust. So, window, let's go out to like 20. Guys and girls, there's too much talking. 300 sounds good.
Yay.
Hey, thanks for that. We're perfect. I can see that graph very well. Okay. Hey, so why is this at 0, 0?
Because it starts at the ground.
Yeah, he started at the ground. that make sense?
Yeah.
Yeah.
So this whole parabola, the time component, which is the x component, makes sense all the way through when you look at the graph. Okay? So let's see, what else do we have to find? Find the time it takes the arrow to reach its maximum height. So we want to have the x component of that. So second calculate, I'm finding a maximum. And 3.4, you think? So I get to the left side of it. Go to the right side. So I'd say I'd try and round it to 3.5. 3.5 seconds after this person shot the arrow got up to a maximum height of 196 feet, but it just asked what was the time at 3.5 seconds.
And 196 is the height.
And then find the maximum height of the arrow. Yeah, the answer to C is 196. We're done with 3. Seem good?
Wait.
Which one?
196.
The time is 3.5 seconds. The height is 1.9 or 196. So that's C's answer.
Thanks.
We good?
Yeah.
Feeling a little better about this?
Yes.
I hope this stuff didn't ruin your weekend. If it did, I apologize.
It did. I didn't have a good weekend anyway. That's
Hey,
sad.
Saturday night, I was supposed to box a guy that was 220. Me at 190. So
What do you do on
they
Saturday
canceled.
Where are you on site?
I got a buddy who's got a boxing ring in his garage in the back of his house,
Fight Club.
No way.
and we do 3-round bouts. It's awesome.
Yeah.
Well,
It's
I
awesome.
was here all
But
day
it's,
Saturday.
I was supposed to box a guy that was 220. I'm at 190, so he had me by 30. And at like 5 o'clock, get an email, hey, got to cancel tonight. Sorry, buddy.
I would be psyched.
Couldn't wait.
I almost had a fight Clay. Parabol my shoulder.
No, we go full wraps on hands. We do full gloves, and we do full face wraps, and obviously a mouth guard because
Thank you.
I don't want to knock my teeth out. My parents would be ticked if I screwed up my teeth after.
I would just go wrestle you.
Your parents would?
Yeah, they'd be like, dude, we spent so much money making your teeth straight, 40 years ago.
Could you live stream your findings?
I
No.
know. She is a bratty bitch.
I'll invite you next time. I'll let you know where it's at.
Yes, I'm buying your full.
All right, a water balloon is dropped off a building. So if someone did this, right? Okay. All right, so number 4. So someone's on top of this building. This building is 80 feet tall, and they're dropping a water balloon off of it, right? Write an equation, modeling this. Okay, so H at T equals negative 16t squared. Why am I using negative 16t squared and not negative 4.9t squared? Because it's in feet. It's in feet. This indicates why that's 16. Okay? He dropped it off the building. Is there initial velocity? No, he just dropped it. Okay? Like I just did my pen.
So it starts at 0.
Yeah, so this is 0t. So your V naught, because it was a drop, not a throw down or a throw up. Does that make sense?
Yeah.
And then what was my initial height?
80.
80. So that's my H naught. Cool?
Yeah.
All right, let's graph it. So let's see, negative 16t squared. I could put this as 0, or I could just delete that out. Plus 80. So notice I don't even have my information in there about the initial velocity. I didn't put 0x in there. Is that okay?
Yep.
Does everyone feel comfortable with that?
Yes.
If I put 0x in there, it's the same answer?
Yes.
It is. All right, so we know that my window, I don't know, we may be able to change that to like 8. I don't know, I'm just going that. That's definitely not 300. Maybe we can go 85 because he's dropping for 80. If I graph it, looks good.
80 is the max, right?
80 is the max, okay? Because he just dropped it. He didn't throw it upward, didn't throw it downward, anything like that. So write an equation. We have the equation on the last board. Find the maximum height of the water balloon. The maximum height of the water balloon is 80 feet because he dropped it from that level. It didn't get thrown up into the air. Find the time it takes the balloon to hit the ground. So a little bit after 2 seconds, agreed?
Yep.
So second calculate. Let's find u0. Above, below, too much talking. So at 2.24 seconds, this water balloon hit the ground. Okay? And then what else do we have? Write a new equation if the balloon is thrown downward at 32 feet per second. Okay? So if I'm throwing downward at 32 feet per second, my V naught's changing. My V naught is going to be what?
32.
Careful. 32t, but it's negative.
Oh.
Why is it negative?
He's throwing it down.
Yeah, he humped it down at his buddy. Okay? So I'm going to change where that 0t was. I'm going to make it a negative 32. And then still at 80 feet though. He's on top of the building, goes like this.
Plus 80.
Right? So, oops, sorry about that. Here, go here, 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 delete that. Okay, y equals, what am I adding to this? Negative 32t. So minus 32x plus the 80 is still there. So that's how that equation changed. If I graph this,
Change it.
why is my vertex backwards?
Because it's negative. Right?
So
No.
yeah, the negative, let me change the window so we can just see it. Let's go up to, I don't know, 120 graph. Okay, so my building's still 80 feet tall.
And what?
So being the person threw the water balloon downward, that water balloon is accelerating faster because there was the initial push. So the water balloon is actually falling from a height that would have been this but it had initial velocity. It's still coming from 80 feet. But the parabola that represents it is a taller parabola. So right there is 80 feet. This is higher than 80 feet. We could find the vertex if we wanted to, but it's going to be weird in the context. It would be like at negative 1.6 seconds, we were at this. Okay, because he threw it downward, or she threw it downward, it means the parabola that represents it falling actually the vertex would be in a negative component. So I can find the vertex of this parabola, but the vertex of the parabola won't make sense in the context of the problem. We have to realize they're standing there, they threw it downward. They threw it downward means it has a different velocity. Right here, it's going to hit the ground at 1.5 seconds, it looks like. So, I forget what this is. Write a new equation, we have that. How long does it take the balloon to hit the ground now? Second, calculate a 0. Got to bring it up. Above it. Below it. So because there was an initial velocity, because they threw it downward, about 1.45 seconds it took the balloon to hit the ground. It hits quicker because it was thrown downward. Okay? What's the maximum height of the water balloon? It's still 80 feet. Even though the vertex is back here, it still traveled. This is the only part that traveled from there to there. Okay? And then last one. You and your friends are hiking in the mountains. You want to climb a ledge that's 20 feet above you. The height of the grappling hook you throw is given by the equation that's given. What is the maximum height of the grappling hook? Okay. So we're just going to graph this equation they gave us. They gave us negative 16x squared. Dude. All of a sudden you see like a lawn chair come in here. Bring a cooler of sodas. Plus 32x plus 5. Okay, so a few things on this problem to think about. You're throwing your grappling hook upward with an initial velocity of 32 feet per second. You're a short person because you released it at 5 feet up when it started its initial velocity. It was 5 feet up when you threw it. Okay? Does that make sense? So they want us to know, did we throw it hard enough that we were able to get it up to the 20-foot ledge above us? So if our y component of our vertex is a larger number than 20, then yes, our hook flew high enough up to get there. Okay, did it get there? I don't know, but it did have the height to get there. Okay, so we have our equation. We graph it. I mean, we can still use this. So you tossed it, it went up in the air. We can go second calculate. We can find a max. So come on up. Come on over. Enter, enter. So at a little over a second, our grappling hook was 21 feet above us. Did we throw it high enough to get to the 20-foot ledge?
Yes.
Yeah. It's a 20-foot ledge. We threw it at 21 feet. So hopefully it grabs onto where we want. We have a good hook. It barely got there, but it got there. Okay? So the last ones, I just want to make the equations. I think you have enough to develop all of this. So number 6 says a diver standing on a platform 24 feet above the pool. He jumps from the platform with an initial upward. Okay. So we have h at t is equal to negative 16x squared plus 8x. And I guess we can make them t's if you want, plus 24. So if you graph that, you're going to be able to figure out when he hits the water. Okay, number 7, a toy rocket is launched from the ground with an initial velocity. When will it be? Oh, that's a good one. Okay, so a toy rocket is launched from the ground with an initial upward velocity of 128 feet per second. So that's x, I guess. Okay, so it's launched from the ground, so that's 0. They want to know, hey, when will this be 112 feet above the ground? So this is a good one. Okay, I like this. Do I have to put the 0 for part of my answer?
No.
Nope, that's just because you launched it from the ground. Let's go ahead and put this in the calculator. 128. Oops. Dang it. Can't have anything nice. 128. X. I guess I could plus 0, just keep that. Graph it. Gotta go a little bit more. Let's go at that to 10 and go up to 300. I like it.
What is triangle X?
Yes.
What?
On the thing.
Don't worry about it. It's a mode we're not going to use. All right, that's our launch of our thing. It launched from the ground, so this is from 0, 0. Looks like at 1, 2, 3, 4, 5, 6, 7, about 8 seconds it hit the ground, but they don't want to know that. They want to know, when will our rocket be 100 and what off the ground? 112? What kind of line is y equals 112? I know it's straight, but what kind of straight line? Horizontal, good. If I graph this, you're going to see a new red line. Does it intersect our parabola twice?
Yes.
So is 112 our vertex? No, it got higher than that. But we're going to find this intersection and this intersection, and that's going to tell our what? No?
How do you do that?
Get the red line?
Yeah.
I did y equals 112 as my second equation. Okay? All right, so let's go second calculate. Now we want to find an intersection. Okay? So this will find one intersection at a time. So it says, hey, first curve, what you want to do is you want to make sure this is close to where you want to intersect. Second curve, guess no. So at 1 second into flight, this is 112 feet up. I forgot what we were even doing.
And then you need to find the other one.
and then I want to find the other one. So at 1 second, and then second calculate an intersection. So then I'm going to move this cursor over closer to the other intersection. Enter. It's going to tell you. And then also at 7 seconds, it's back to 112. I flew up above that, flew below it. Okay? All right, I think we're good. So let's make sure you hand that in tomorrow. Okay? I have some notes. These are kind of a flow chart for doing these problems. If you like this, cool. If you're like, I don't like it, recycle it.
Is this more graphic calculated stuff?
Yes.
Wait, do we have homework on Halloween?
Heck yeah, dude.
Trick or treat.
Thank you.
There's 3 there. Stealing kids' candy. I get 10% of the loot.
What?
I feel like his sister would hand out math homework to the people trick-or-treating at his house.
No.
What happened on Friday?
Yeah.
Did you play?
There's some BS
Is this whole unit gonna be that calculated?
Too many. Oh.
A first. It's a first. A real one.
I thought it was 14.
It takes like 1 second to reach that.
Wasn't it 14?
1 second and then
Sam, bro. Sam out 2 buddies.
Oh! What? I don't want to try.
We need more.
Oh my god, I've seen so much.
All right.
If what one's
Thank
on
you.
there,
This class.
they showed us for 6 5
Oh, yeah, I'll just throw them off. Yo, that's a different class.
All right. So we are still walking along with these quadratics. Okay, we're just a little bit more, still using the graphing calculator. So they tell you by this equation, we're not doing free fall on this one, but they said the price of gas was modeled by the quadratic function 0.23x squared minus 0.05 or 0.506x, bless you, plus 3.14, where 1 represents March 1st. So 0 would be February 28th or February 29th, depending on if it's a leap year. X equals 2 is March 2nd, etc. What was the price of the gas on March 17th?
$2.50.
Okay? So, your initial starting is 314. So let's see if we can start figuring this out. Yeah, look at this. Go here. Y equals clear. And we have 0.23 x squared minus 0.506 x. Oops. X plus 3.14. Okay? So if we graph this, I don't know what gotta get this y2 out of there. Clear. Graph. It's parabola, it opens up. Let's go. Let's change the window a little bit. Let's go to like 40 days out. So it's a parabola that opens up. So what was the price of gas on March 17th? So these are March 1st, 2nd, 3rd, 4th. That's what the X is. So if I do this, if I go second calculate, and I want to find a value, and I want to find the value at the 17th, that tells you that the price of gas is $61.08. If we don't put this in right, did I put that in right? Jeez Louise. 0.23 x squared minus 0.506 plus, yikes, okay. Which day in March has had gas prices that were minimum, well, that would have been at the first. So I can do this. I can calculate. I can say, let's find a minimum. Let's go to the left side of it. Let's find what the vertex is. So I'm coming back up. Enter. Go to the right side of it. Coming back up. Enter. Enter.
Yeah.
So that first day we're at $2.86 a gallon.
Yeah.
What was the minimum price in March? $2.86 a gallon. Yikes. I don't like modeling stuff after that. Okay, second page. Maximizing area. Maximizing area. Set x equals the width. Find the length of the expression L by subtracting the widths from the given amount of fencing. Divide by 2 if both lengths need fencing. Okay, what is the maximum area of the equation? What is the width that maximizes the area? Find the dimensions that maximize the area. What is okay. Okay, let the lengths L by subtracting the widths XS. Divide by 2 if both lengths need fencing. Okay. So I think what they're saying is this. This is x. Find the length of the expression L by subtracting the widths xx from the amount of fencing. Divide by 2 if both lengths need fencing. So this is xs over 2 because this and this would need it. This would also need it. But then this is just xs, xs, xs. That's how I'm reading that.
I think you an excess amount.
Gotcha. What is the maximum area of the equation? Oh, those are supposed to be just x's. I don't know why the x, and then yes. So set the width that the length L by subtracting the widths. Okay. So I think it's going to be this subtracting, so x minus 2x over 2 minus 3x. So that's going to be x minus 3x. Yuck. All right, so that's going to be minus 4x, what those come out to. So x times negative 4x is going to be our equation. What width maximizes the area? Dude, I don't know who wrote this question.
Why would it be x
Man, that
minus
was an
6?
excellent question.
It was
Why is it x times negative 4x?
because the length is x,
Yeah.
and then the widths were given by.
Okay.
Okay, so y equals. Oh, got it. Can't have nice things again. There. X minus 4x. Delete. What was my equation? X times.
That's not an x.
It's not. I was thinking. Love you.
Minus 4x.
Minus 4x.
Negative 4x.
Like, you know. There's not one bad. It's like, the graph is not collected.
That?
Yeah. It's going
And
down.
that's my job.
Yikes. Zoom standard.
Oh. I feel like
I don't like this one. I'm moving on to the next one. I don't like how this one's phrased. I don't like it. Why don't I like how it's phrased? Because I'm not figuring it out right away. All right. All right, so the rancher has 600 feet of fence to create 2 animal pens like the ones below. Animal pen, animal pen. Part of it's going to be against the barn, so you don't have to fence against the barn because the barn's an edge of it. So since the pen's against the barn, no fence will need to be there. What should the width of the fence be to maximize the area of the pens? Okay, so I'm going to do this. If this is x, and this is x. You still with me? Okay. So x plus x is 3x. So this right here is going to be 600 minus 3x. Why is it 600 minus 3x?
Fencing you'll be able to use on that area.
Yeah, 600 feet of fence. You're going to take away the same component. You're making these into fences. This is going to be like x, and this is going to be like x plus 4. Okay? So length, width is that. Length is going to be 600 minus 3x. Okay? Find the maximum area equation. So I'm going to go x times this. All right, so x, and then was it 600 minus 3x? Is that what it was?
Man, this math is really exciting.
Sorry.
Don't come to class, you know. Just say shit.
Bro, how's the sun going?
Window.
Did he spell always with 2 L's? Probably. Hey Sam,
What?
how do you spell always?
Oh yeah, my bad.
Holy cow.
Let's say.
No, spell it out loud.
She's strong.
Spell it out loud.
No,
Nice. Be nice. You're mean. Be nice. Oh my god. He's a
Yikes.
There's not 2 L's, there's only 1 L.
Yeah, I know. This supposed to be.
This is my grade level. It's not like it's advanced for us. It's advanced for us because we're in Europe. Just whatever. I think it's the point.
I can't even get to the maximum. All right. Why don't we say we try Q? Try Q? Try Q? Sound good? Try Q. Make sure I have your calculator back. Take care of one another. Have a great day. Sorry I didn't get all the way through it. And then bring these notes back tomorrow because I'm not done with them. Cool? All right. Have